All right, let's start talking about pre-change validation. When you look at it from the perspective of software development overall, there is this concept of linting where utilizing pre-change validation constructs in software to make sure that the code matches or is in compliance with a specific set of parameters that an organization uses to define how the code should be written. So when you look at it from the perspective of network as code, it is a very similar concept. You're performing pre-change validation that happens at the source code level. So this is not talking to devices or anything like that. It just happens to the data model structure in itself. And this allows us to have formatting checks, syntax checks, semantic checks, and compliance checks. So this is divided into different contexts, and we will look at each of those individually or separately. If we look at the following data model, what you'll see here is a representation of a bridge domain inside of an ACI fabric. I'm just using a generic construct. You really don't need to get any specifics about it. For Nexus dashboard, it would be different. For SUN, would be different. For every element, would be different. But the overall structure or concept that we're talking about is going to be the same. So in this case, each of of the attributes in this structure of data is defined inside of a YAML construct. So we know what each of these values is supposed to be. So with the command NAC validate, it will take this known schema and verify it against that data model that you have. So let's take the first really easy example of this is if we're looking at this MAC address. And the MAC address needs to be formatted in a very specific way to be valid inside of the schema. So if the user incorrectly enters the MAC address, then the validation code will reject that the MAC address overall and say that this is not a valid configuration parameter. It also can look at things like a numeric list to say that the only potential values that might be inside of this element are, let's say, encapsulation flood or BD flood or drop. So it's only possible 3. If you were to add something different, then the validation will also fail, and you would be in the position of having to readjust those parameters to meet the expected values. And this goes across the board through the whole set of the data model, each individual one. IP addresses are properly formatted, both v4, v6s. And then other values might be defined only as strings, meaning that if it's a name, it needs to be a certain way. Outside of that, there's also a concept of semantics and compliance validations. And this is where we extend the data model, NAC validate code, to also run through and do verification of parameters based not on if the value is a correct value, but if the value is allowed. So if we take a simple example in ACI that the business qualifies and says we don't want any of the bridge domains to be defined as having a public true, which means that their routes would get leaked out to an L3 out, you can define that in a rule set, and then when it runs, it will indicate that to the operator that that value is not allowed. And these are different types of ways for us to make sure that the compliance side of the house is met for a customer before going to devices in the network. So as an operator is working with the data model, making changes to the data model, implementing stuff, that these things can be checked at any point in time. And with that verification, it allows us to make sure that if there's something wrong, it's not found when automation runs, it's found early, it's detected early, and it's stopped early, avoiding problems during automation execution and production. A good way to understand how pre-change validation works is to look at it from the perspective from a software development lifecycle, to integrate all of these components together and see how it would work overall. So the best way to understand it is from a branching strategy. So you're working on network and you see, how exactly NAC validate is going to avoid any problems for me. It's good to see it from this perspective. So let's first start with something like a main branch. So if you have a main branch, usually this branch is what we call a protected branch. So people are not working directly on this branch in itself. It's only, code gets to it only from merges into that branch. So what ends up happening usually is you end up with another protected branch we call the develop branch, which is it's branched off from main, and it's kind of like this primary area where everybody ends up forking from that, working with it, and sending stuff back, and eventually, in a real production network as code environment, that main branch is going to exist to receive at some point changes coming from the develop branch at some specific time, and nothing really goes directly from is pushed directly to the main branch itself. So when we look at it, right, the first step that happens with the network operator on the environment is they'll fork that develop branch and they start working on that branch. Now, that is somebody's personal branch overall. So separate overall from that fork with permission structures in there. But inside of defining that, you can create a structured way of having to make sure that that person's branch would work. And we usually do this through what we call pre-commits. And there's, in essence, done is built inside of the structure. You can have operators sit down and create specific elements that are part of the repository code that run and say, we're going to perform two specific tasks. We can do YAML linters and we do NAC validate. And then what happens every time a person commits to their own branch, these would run and would alert them, say, hey, we can't commit this code because this has this error. This is not linting correctly in YAML, or there is an error inside of the schema overall that is not going to work. And as you continuously commit, the same code is run and run and run on you to make sure that you're following or sticking to the right structure of code. Eventually, you get to the point where you do a merge or a pull request. And what happens now is that we take that and embed that into the primary repository code. They would run the NAC validate as part of the merging process. And now the pipeline on execution sees this, and if there's any errors, it will avoid that merge from happening back into the develop branch. And as we progress, it's the same structure. Another merge is going to happen. It's going to go back into the main branch, where then a merge happens. And then when that happens, a full structured validation occurs. In this case, we're really simplifying it, but overall, to give you an idea, that NAC validate is run before the automation execution is run to make sure that the data is correct and structured correctly for the automation engine.